Juan Pedro, ya te veo conectado. Me da mucho gusto. Hola,
Listo.
hola. Ajá, qué bueno. Algo fallaba con el dato de todo. Te he mandado directo el completo con el dato y todo.
Sí, buenísimo. Había un dígito de más que no me permitía introducir, pero corregido todo muy a tiempo. Gracias.
Excelente, excelente. Qué bueno verte después de mucho tiempo.
Tiempo, sí, sí, sí. Deja saber cuando vengas por Lima.
Sí, gracias, claro que sí. No sé cuándo será. Este año sí es. Me están invitando para mayo, me están invitando para julio, me están invitando para agosto, pero todavía no lo sé, pero sí te aviso.
Me encantará, me encantará.
Sí, muchas gracias. Así que vamos a ver. Los alumnos que tengo, me parece, no sé si el IVA va a venir hoy día. Estaba viniendo, pero pues, por el trabajo de repente no viene, pero se conecta en vivo. Así que eso va a ser una buena cosa. Y el otro, Brad, trabaja en una mina, me parece que en Nevada. Así que
Wow.
no aparece en directo, pero sí responde y sí hace. Y de hecho es posible que les haga un quiz de tu presentación para que respondan algunas preguntas directamente de lo que estás explicando. Así que
Ya.
ya, así que eso va a ser bueno. Faltan muy pocos minutos, 8 minutos, pero sí, empezamos cuando esté ahí. Bueno, me alegra verte y saber de tus progresos y todo lo que están haciendo con Stargate y todo en general, con todo lo que está ocurriendo. No sé si todas estas eh, proyectos, bueno, entiendo que va a ser la expansión de la base naval del Callao y posiblemente empiecen a hacerse cosas con lo de Talara. No sé mucho, pero sí trato de seguir, digamos, los temas, ¿no?
Sí, te agradezco. Te cuento que he tenido que iniciar una acción legal ante Indecopi porque la FAP sigue sin entregar pues la información que les he solicitado
Ya,
y eh, esta acción ante Indecopi, el órgano de competencia, me va a ayudar a empujar eso. Debo tener una decisión admitiendo mi denuncia antes del fin de este mes.
ok.
Eh, y supongo que eso nos va a convocar hacia el tener que conversar. La FAP ha estado, creo que más ocupada en los proyectos de las compras de los cazabombarderos que van a reemplazar los antiguos Mirage.
Sí, sí, sí.
Este, y pensaría que ha sido esa su prioridad, pero igual, mira, nos estamos atrasando y ya leo que está entrando inversión para el mismo propósito a Chile y también a Ecuador.
Mira,
Y casi 2 años perdidos sin tener noticias de la Fuerza Aérea.
caramba. Mira, pues. No, es.
Pero no importa, a mí ponme a pelear por algo, soy abogado, yo soy un Doberman, así que no hay problema.
Qué bueno, qué bueno, qué bueno. Sí, no, voy a ponerme así para poder conversar, pero lo que pasa es que no. Creo que.
No, ponte cómodo. No, sí,
Ya,
sí veo tu imagen, te cuida.
perfecto, perfecto.
Sí veo
Este,
tu imagen.
voy, voy a presentar en Salt Lake City dentro de 2 semanas. Me voy para allá para ¿cómo se llama? Es la sociedad, el SME, la Sociedad de Ingenieros de Minas. Bueno, es
Ah,
mineros metalúrgicos. Y tienen una sección de minería del espacio. Y
qué maravilla, qué maravilla.
han aceptado un paper que estoy trabajándolo con unos chicos acá. Muy ambicioso, quería hacer machine learning para seleccionar qué cráteres sí, qué cráteres no, de un sector muy bonito. Pero ya, bueno, voy a tener que, a ver si tenemos 5 minutos, te puedo mostrar algo muy, muy, muy sucinto, pero que te puede dar un poquito la idea de lo que estamos haciendo acá.
Pero qué genial.
Ajá, está en borrador todavía, pero ya que estamos acá conversando, te voy a compartir mi pantalla y vamos a verla juntos un momento. Así también pruebo como esta Salt Lake City. Entonces, La idea es, a ver si la ves.
Sí, sí.
La ves bien. Ya, ahí está. Ok, es una estrategia de Machine Learning. Lo estoy haciendo con la doctora Natalie Rizzo y me ha dicho que de repente baje un poquito la ambición de hacerlo con Machine Learning, hacer simplemente una cosa más general. Pero igual, el fondo que vemos ahí es de una cordillera que se llama Shackleton de Gerlach. Es una cadena de cráteres que me interesa ver. Y ahí estoy con alumnos y con la profesora. Entonces empezamos con la Luna y luego al Polo Sur, que es el lugar más ambicioso para poder empezar las operaciones. En particular, ahí ampliando, ahí está el Polo Sur. El Polo Sur está bordeando un cráter gigante que se llama Shackleton, que es totalmente oscuro, entonces no podemos ver nada. A la izquierda tienes de Gerlach, que es otro gran cráter, y aquí en el medio de los dos está esta cadena de cordillera, le llaman la cordillera Shackleton de Gerlach, donde están los cráteres que me interesa extraer. Eh, la escala, bueno, acá tenemos Shackleton es más o menos 21 kilómetros de diámetro, es inmenso y es negro, negro, oscuro, como una refrigeradora gigante. La temperatura está creo que a 300 bajo cero, o sea, hielo permanente si es que encontramos hielo ahí, parece que sí lo hay. Hay acá, Spudis creo que no, pero hay en de Gerlach y hay en algunos otros sitios, Amundsen, por acá, bueno, y otros lugares. Entonces, ahí está, el Polo Sur y la zona de interés en la que vamos a trabajar. Ampliado, así, ampliado acá está los nombres, he conseguido los nombres de cada cráter y mira la escala, estamos a 1 kilómetro, o sea, 1 kilómetro es este pedacito, así que tenemos más o menos unos 20 kilómetros de cráteres. Están un poquito en un promontorio acá, algunos están en el borde del cráter. Y una parte interesante es esta, que es el borde mismo del cráter Shackleton. Está permanentemente iluminado, siendo el polo sur, porque esta parte está bien elevada, esta cresta y esto se llama la zona de luz permanente. Entonces, yo puedo tener acá un punto de partida y de repente una visual para tener el acceso a los paneles solares o la electricidad de los paneles solares y acá tener un centro de carga. Entonces, yo voy a minar acá, regreso, voy a minar acá, regreso, voy a minar acá, regreso y siempre puedo cargar. Puedo cargar acá y también acá puedo botar todo el material, apilar el material que voy a extraer. Entonces, algunas de estas zonas son más oscuras que las otras y hay probabilidad de que tengan ah, agua. Entonces, eso es al principio. Y aquí está, este es un análisis, este es un bonito software que me da las zonas azules, son las zonas de oscuridad permanente. Es decir, siempre van a estar oscuras. Es una ventaja en el sentido de que ahí debe estar guardada el agua. Y en el otro caso es que es difícil es entrar ahí, es muy oscuro, pero que lo hagan pues los equipos que vamos a enviar. Esta es
Eh,
la geología del lugar. Esta es la geología. Entonces tenemos básicamente la diferencia es los tipos de material, la dureza o la rugosidad, y esto es para diseñar cuánto energía voy a consumir en mis equipos para poder lograr mi cometido, ¿no? Por ejemplo, entro acá el material es más o menos esto, ¿cuánto es? 90%, pero aquí es 30, 40% de tres tipos de materiales. Acá también tengo dos tipos de materiales y así, entonces algunos cráteres van a ser más fáciles para entrar y salir que otros. Esta es la vista, pero ya con colores. Estos colores son de alturas. Esta altura más o menos está en 1700 metros y más o menos, y acá está en el borde, pues cerca del borde está en cero, pues, más o menos en la altura de los cráteres. Aquí está el famoso Shackleton. Y acá los diámetros he medido manualmente cada diámetro, el software me lo permite. Y acá, esto es de un estudio que han hecho antes, los tipos de roca que vimos en el gráfico anterior, ya hay identificados visualmente su rugosidad, sus características, ¿no? Algunas características físicas. Y acá tres zonas de riesgo, dice, riesgo incrementado, riesgo extendido y otro lugar seguro. Quiere decir que debo inclinarme a trabajar en estos cráteres De hecho, este de acá, Worthy, es un cráter que trabajé con un ingeniero. Presentamos esto para el año pasado, sí, el año pasado para la Sociedad Lunar, para poder sacar material de acá. Y esto, bueno, no está muy claro todavía, pero esa es la vista desde el norte hacia el sur, de donde sería la cadena de cráteres. Solo se ven algunos, pero ya tengo algo. Bueno, todavía hasta esas son las rutas que estoy planeando. No sé si es la mejor, pero al menos es un punto central donde yo puedo cargar mis iPEX, que son los equipos cargadores, ir y recoger y acá apilar el material por acá. eh, 2 kilómetros cada uno, más o menos. Estamos en la hora. Y bueno, eso es todo lo que tengo por ahora. Espero.
Oye, Tito, y ponte tú para tu escuela, tu escuela de minas, ¿haces campañas de reclutamiento para alumnos?
Sí, permanentemente. Invitamos a la gente que venga. Tenemos chicos que van, bueno, normalmente van a todo el estado de Arizona, pueblo por pueblo, ciudad por ciudad, escuela por escuela. Y se promueve, se pone una mesa, todo. En Salt Lake City vamos a tener una mesa también, donde vamos a
Mm.
tener algunas cosas. Y a veces llevo modelitos, cosas, pero en realidad más es para lo que es minería, minerales, algunos equipos.
Es que tú sabes, me parece impresionante y te felicito, pero qué maravilla la tecnología. O sea, esto es trendy, o sea, es trendsetter. Yo
Así,
quería, oye, sugerirte, esto está como para hacer una presentación de impacto ante un público minero, inclusive,
y,
para abrirle los ojos de cuán avanzado está esto. Por ejemplo, yo te sugeriría, pues, que te busques presupuesto y tengas un stand para la universidad en Perumín. Imagínate que viese esto la gente en Perumín. O
sí,
sea,
sí, sí. Casi ocurre. Tú sabes que en agosto yo no podía ir, pero fue mi jefa, la directora de la escuela.
ah,
Peso pesado. Y un chico que se dedica exclusivamente a outreach, o sea, a buscar alumnos. Y hubo muy buenos contactos, todos quieren ir de nuevo. De repente me dicen, me toca ir, por eso digo agosto, podría ser que, no sé si
oye,
el
pero
siguiente.
sería ideal y que presentes este
Así es.
programa, pero la gente se va a volver loca. O sea,
Sí,
olvídate, qué
sí,
tan increíble la tecnología,
así.
increíble.
Y hay varias cosas más cuando estaba hablando con Seti Gabelán, que es uno de los directivos del gerente, creo, del instituto, me dijeron, oye, vente que vamos a tener una sección de la lunar. Iban a traer un equipo, bueno, no, no sé si el equipo o una presentación, creo que querían traer el equipo que es el IPEX, o el IPEX, ¿no? Que es este que excava así como un barrilito adelante. Pucha,
Ya.
ya me engancharon ya desde Hello. Pero no lo trajeron y terminaron llevando unos folletos y cosas, un video, pero eso también lo hago acá, así que no, no había mucha novedad. Pero yo quiero ir más allá y trabajar con la gente de On World, por ejemplo, que tienen unos equipos de minado continuo y todo, ¿no? Así que vamos a ver por partes.
Te felicito y
Very-
gracias por mostrármelo en
oh,
exclusiva.
excelente.
Lo voy a
Así es.
comentar.
Sí, sí, y lo voy a terminar y te voy a presentar, te voy a entregar el trabajo terminado. Así que eso cuenta con eso. Ok.
Muchas
Muy
gracias.
bien. Bueno, acá tenemos a Levi Gann. Vamos a empezar. Voy a switchar a inglés y podemos empezar la clase. Ya estamos en la hora. Ok, Levi, this is our guest lecturer today. Wonderful. JB, Juan Pedro Van Hasselt from Peru. And he's going to talk about many of things. First, I'm going to uh, introduce him, and then please stand up here for saying hello directly. Sure. Okay, I'll start here with this. So, good morning, everybody. Good morning, Levi. Good morning, Brad. I'm very happy to have you here, and also today we have a special day because we have a distinguished guest lecturer, Juan Pedro Van Hasselt from Peru. Going to read his bio here. Executive specialized in legal corporate issues with more than 30 years in business management in leading multinational and Peruvian organizations, acquisitions and mergers in Latin America, compliance and good corporate governance, company law, competition law, negotiations, telecommunications, mining, construction, energy, environment, investment, and trademarks and patents. Relations with the government and third parties of interest, stakeholders. Also, former justice and member of the advisory council of the Peruvian Competition and Intellectual Property Agency, which is called INDECOPI. Founding partner, director, and general manager of Stargate Peru, SAC, which is the central business now. And Peruvian attorney with a Master of Comparative Law, American Practice, from George Washington University. Independent director, compliance and risk officer. His interest in science and innovation led him to research and persuade the Peruvian Air Force to consider a proposal to enable Peru to build their first spaceport, which will allow the country to enter the new space economy of this 21st century. So, without any further ado, first we will have Levi here. Please, can you stand up here, therefore?
And shut it? No.
Yeah.
Hi, Levi Gant, Masters of Mine Engineering. I was actually just in Peru a couple of months ago. Beautiful country, beautiful nation. Looking forward to hopefully being able to go back in the future. Had an interest in astronomy since I was a child. Was really looking forward to this class ever since I heard about it. I'll be graduating next semester and consider pursuing a degree in law. So very excited to meet you and looking forward to the lecture. Thank you.
Thank you.
Very good. And the other is Brad Rudy. He's in a remote site now, and most likely that I will be happy to share emails, so there will be further communications in the future. Okay, very good, excellent. JP, the stage is yours. Let me share my give you privilege for sharing your screen, or I'll open the
Presentation.
I show here the presentation here, and in that way I will. Oh, I'm calling you. I guess I'm sorry. It's me. Okay, let's do it. I'm sharing my screen, and let me open this in the D12 already by space. Ready? I need to give me a moment.
Sure.
And then okay, yes, there you go. Oh, of course. Here we are. Okay, you were duly announced for today, and as a reminding, and I really have your all the way down to the lectures. Okay, we already have you here. Here you are.
Oh, there it is. Okay.
I'm opening, and all right. Okay. Yes.
There we go. There we go. Thank you so much, Professor Tito. Very honored to be once again summoned to make a presentation about asteroid mining, but taking place in the future from the Southern Hemisphere. Next page, please. This starts as a project partly inspired by what is being done also in South America. You can see the map on the left, which is a section of the Americas. Yellow, highlighted yellow, is the map of Peru. And we are facing the Pacific. And if you see a dot towards
excuse me.
oh,
High video.
one less. Yeah, one less.
Yeah, my bad. Okay, excuse me. Okay, go ahead.
There we go. There's the map of Peru highlighted in yellow, facing the Pacific Ocean. And if you turn towards the east, you will see a black dot there, which is the Guyana Space Center, which was entirely funded by the European Space Agency. As early as 1979, they started building this when all of us, I think all the Americas, didn't have a clue why were they building a space center over there in Guyana, so very remote. Well, they knew it all along. It's the convenience of launching from the equator. As you will know, Earth is a circumference, an irregular circumference, flattened by the poles, with bulges along the equator. And at the equator, the rotational speed is the highest on Earth. You very well know it's 80,000 kilometers of circumference divided by 24 gives you a ground speed of 1,670 kilometers per hour. Why is that important? Because at launching, this rotational speed gives a thrust to rockets, which means like savings of 30% in fuel or a payload increased by around 30% as well. So there's a science behind being located on the equator. Back to the map, we see that major rocket companies and artificial intelligence companies are located in California, as you very well know, in Washington State as well. And what we have followed in scientific literature is that this location, there will be a cross-pollination between space activities and AI. So imagine the potential of rockets or space-related items that will be launched in the years to come. We will be alive. We will certainly be seeing them. But again, our case here is that we show in the map how we're only half an ocean away, around 1,800 nautical miles from California. And the access would be very easy to the north of Peru. The space station would be roughly 4 degrees south of the equator, and we think it'll be a hub for launching. But you will tell me, but JP, we're talking about space mining. Patience. Why Peru? Why Peru? Peru has a millenary history of mining and metallurgy, back from the Incas, before the Incas, the Chavin culture. And we want to capitalize that knowledge of millenary mining science to become a hub for space issues. Mining is a big thing for Peru. Peru is considered among the top 5 countries regarding in the West related to sourcing minerals, together with South Africa, Australia, Canada, Chile, and Peru is up there. To give you the facts, for example, from EY study, you can see it on the right hand of your screen, top 2025 by EY. We are rated number 2 in copper, globally, number 2 in zinc, number 1 in gold, number 3 in silver, number 4 tin, and number 3 in molybdenum. what does this mean for Peruvian economy? Around 57% of our exports are mining related. It captures around 11% of private investment. Our GDP is on mining production is 11%, tax revenue 8%, and employment around 5%. Now, since we are dealing with EY, I would believe that these figures are related to solid businesses, are extracted from solid businesses. But we have a huge problem regarding illegal mining in an informal economy. So I would say that even the GDP and the employment rate would be much higher if they were real figures. But again, based on the source EY, I think they are only considering a formal extraction. Next page, please, Professor Tito. Case in point, for example, the PGMs. You very well know platinum group metals. Huge for not only electromobility, but even for internal combustion engines. Internal combustion engines, platinum, palladium, rhodium, ruthenium, and iridium are all needed for catalytic converters in the internal combustion engines because of, again, environmental laws. PGMs, for example, are becoming a concern for the industry. And we'll speak about major geopolitical concerns at the end of, almost towards the end. But again, see how this activity, the mining activity, cannot be seen isolated by itself, but in conjunction as to what is going on in the world. The map on the right of the screen, for example, where are PGMs found? According to the map, the sources, the U.S. Department of Energy, 80% of PGM production and reserves are defined in challenging geographical locations. South Africa, probably civil unrest, political instability. Zimbabwe, same thing. And Russia will always be an adversary to the West. We can see how they are performing in Ukraine. How can you rely on a group of metals important for your technological industry when 80%, as defined by the U.S. Department of Energy, are sourced from challenging geographical locations? So, case in point, maybe we should look up to the skies for space mining. Next page, please. Good news is that, as you know, there's, as I define, some present-day pioneers. We have in the U.S. Matt Jalich spearheading Astroforge, who's already engaged in deep space mining. And I love this image here. They appeared last year in CNN, and I get extremely contagious by the excitement of the CNN anchor host. And you should try to find this interview because they're already broadcasting that space mining is a big thing, and probably soon it'll be a normal activity for all of us. The best example so far as I have researched, next page, please, Professor, is what Mitch Hunter Scallion is doing, spearheading this British enterprise called Asteroid Mining Company, AMC. They have, first of all, looking on the right, the black and the black graphic over there, very ambitious. I have underlined part of their vision, 3 lines towards the top. They even say they have the intention of being profitable long before we get to an asteroid. I mean, either they're so ambitious, imaginative, or they know something in science that is not being disclosed. But what a ambitious goal, and I'm very impressed by what they are doing. Further than that, I'm also impressed because they obtained funding of 500 pounds, 500 million pounds from the British government. And what have they done? Part of that funding has been given to the University of Glasgow, huge also on mining. And the university has a spectrometer. And what they are doing is, as per the mission entrusted by AMC, they are preparing a roster, an inventory of every single asteroid of the 74,000 and counting asteroids in the asteroid belt between Mars and Jupiter. So you could say that probably in the past, the task was to visit an asteroid and explore and find out its composition. Not now. What AMC is opening the ground for future exploration is by making this inventory with a spectrometer, and every single asteroid, the X94K or whatever, will be completely analyzed regarding its composition, and whichever mineral will be needed to explore, there will be a fixed target. So I'm very amazed by this other pioneer. Next page, please. But maybe, for example, you would think, well, space mining is like a brand new activity. For the life of me, I cannot conceive how somebody back in 1979, when Alien, the movie, was released, even imagined that there would be like a refinery in space that we would be bringing minerals. According to the legend, the Nostromo hold a mile-long ore refinery on its final voyage back to Earth, processing 20 million tons of raw ore. You know the story. They received an SOS, a hail from a distant planet, and they, because of Admiralty law, the law of the seas, they are obliged to provide rescue. So they did, but we all know it was the error, and Earth was condemned. So that's the story. But I'm fascinated by pop culture, imagining space mining back in 1979. Probably when I saw this as a kid, I would say, well, I mean, this is a fantasy like Santa Claus. But see where we are in the 21st century. Wow. So if somebody has a reference of space mining, which is earlier than 1979, please reach out, because I need to change this graphic if so. Next page, please. In another case for space mining is also the impact on the environment. The graphic on the left shows the calculations in carbon for the extraction of 1 kilogram of platinum on Earth. 40,000 carbon units in kilos. But what if we would adventure into space and bring 100 same kilogram of platinum from the nearby asteroid, from the asteroid belt? The impact would only be the exhaust fumes from the rocket, and that would amount only to 150 kilograms of carbon. So you see, terrestrial mining alone generates 40,000 kilos of carbon, according to this comparison. We're moving towards a greener environment that might also push mining activity towards space. The source, if you would like to see a complete explanation on this, the video on YouTube is called Asteroid Mining: How to Mine in Space Instead of on Earth. The documentary is by the German Deutsche Welle. On the right, demystifying the impact on the economy, what it takes to build an electric vehicle and its battery. For example, this image of this blue car. There is a graphic showing the batteries. They are heavy. They cost like 1/3 and a half of the total vehicle to be replaced. Battery life is estimated at 6 years. So there are pros and cons. But what it takes regarding mining: 12 tons of rock to extract lithium, 5 tons of cobalt minerals, 3 tons of mineral for nickel, 12 tons of copper ore, moving 250 tons of soil to obtain 12 kilograms of lithium, 13 kilograms of nickel, 22 kilograms of manganese, 7 kilograms of cobalt, 100 kilograms of rams, 200 kilograms of aluminum, steel, and plastic. And then you have the what is called the yellow hardware. The caterpillar for earth moving requires 1,000 liters of diesel. Roughly, that would be like 400, 500 gallons, US gallons of diesel, not to mention all the other equipment. And that's, you need to haul all these extracted minerals to China, where probably this Chinese, to a Chinese factory, which will manufacture this electric vehicle, and shipped way back to the Americas and Europe for to be consumer ready. So, I mean, that's a huge impact. Another argument towards space mining, right? To obtain all these minerals with minimum impact to Earth. Next page, please. Well, my dear viewers, probably this is the awful part, the regulatory framework, but I'm a lawyer, I wouldn't be here. So I need to convey this boring part of the presentation. The laws governing the extraction of minerals and profit obtained from the planets, it comes from the Outer Space Treaty, an international agreement that binds parties to use outer space only for peaceful purposes. This originated in the Cold War, when Russia was winning back in '57 the space race. The satellite is called Sputnik. Yeah, when Sputnik was launched in 1957, then came the dog Laika, then came astronaut Yuri Gagarin. So Russia was winning the space race, and this placed This surprised the Western Hemisphere, not only the US, but Europe. Remember, we had just come out of the Second World War. Russia was kind of an adversary. Berlin was separated in two cities, and there was a lot of fear in the Western Hemisphere on what if Russia would be predominant in space. So they pushed for the Outer Space Treaty, specifically indicating that space is only for peaceful purposes. And I cannot remember if Russia is a party, probably is, but several countries have taken steps to address the emerging field of space mining. There has been a thrust, but mainly by the private sector, and this is due to the Artemis Accord and new regulations issued by United States on the commercial use of space since 2015. And Luxembourg also enacted its own unilateral laws. And there are a couple other countries, United Arab Emirates, Japan, Russia, and China. Even Peru has drafted a bill inspired to the Luxembourg Act and the U.S. Commercial Space Launch Competitiveness Act, because we see that this is a major trend. No matter what, we need to go to space. And we'll talk about it shortly. Next page, please. In this presentation, I not necessarily wanted to convey issues regarding technology, but what is going on around the world as when we started this presentation. The U.S. Space Force, which was created by President Trump in his earlier administration, and it will become a concern as well. While reading through this page, which was of this brochure, which was shared to me, see that on the next to last paragraph, there is key wording, no? How the commercial sector can support national security. Support, commercial sector support. So what is the main concern? National security. Reading this from my experience dealing with U.S. governmental issues, what we may be seeing in the future is that overwhelming national interests, the government can somehow order the commercial sector to take one or the other path as may be requested or mandated. I don't know. But we are dealing with defense strategy issues, and we should not see space mining as exclusively a commercial activity. So what I want to stress here is that we should be sensible to the impact that this activity could have not only in the host planet, but on Earth, among dominant countries of Earth, and even on your everyday activities, as I will probably elaborate later. I mean, I'm sorry you didn't say so, but if you have any questions, there might be pertinent to the particular section, so please feel free to raise your hand.
Okay, we'll do. Appreciate it.
Okay.
All clear now?
Good.
Okay. So now humanity, I would not say we, because this is a U.S. operation. Humanity is going back to the moon after 40 and something years, I think, with Artemis 2. They were supposed to launch on February 6th, but there's been a postponement due to hydrogen leaks, as I can recall. So the operation has been postponed to April. This will be, space mining in execution. The object of Artemis is to establish a long-term presence in the moon, science, exploration, and be the platform to launching humanity towards other locations, mainly Mars, as I understand. Next page, please. Yep. From the moon to Mars, stepping stone and testing ground. What happens regarding the moon? It's the moon, because of its proximity, can use a crewed mission to get to the moon in just 3 days. They do not need to get out of the atmosphere. They are in the space vacuum and easily reach Mars. Round trip mission, if they would take place from the Earth, it would take at least 7 months. NASA will be paying close attention to the effects of limited gravity or microgravity on the human body during crewed flights to the moon to assess the effects of long journeys to Mars. These activities are essential because different environment, distance. Probably if you go to the moon, maybe there will not be a return flight. Maybe a colony will be established there, and the conditions, as we have read, are more harsh. So it will take a lot of science, and the moon will be like the stepping stone to go to Mars. Of course, they will be, again, talking about paying attention to issues. There will always be detractors. In this case, not necessarily space mining, but there's, for example, Mark Ruffalo, this actor, who's very vocal on all things against Donald Trump, Republicans. And I see, for example, in this post from X, he's against Elon Musk on spearheading the projects to the moon. But again, those are issues that we must be sensitive about: positive criticism, negative criticism, and so on.
Yes.
Another issue has surfaced regarding a meeting that took place just recently on February 4 in the White House. Why am I telling you this? The White House set a critical mining interministerial meeting to assemble a cartel, which is called the Forum on Resource Geostrategic Engagement or FORGE. As they say, what they want is to have, first of all, China's position on maintaining the stability and security of global critical mineral industry and supply chain remains unchanged. China maintains countries that follow principle of market economy and international trade rules. The U.S. has just moved to build a critical mineral group, but this is on Earth. China is with its 5,000 and so years as a society, has been working way before on that. Where is this? Okay. For example, on January 29th, I mean, just 4 days before the February 4 meeting at the White House, the China Aerospace Science and Technology Corporation officially launched the Tiangong Kaiwu, if you excuse my knowledge of Mandarin, their sky exploration project, making a new cycle in China's deep space exploration, transitioning from the exploration and verification phase to resource development. This leap represents not only an iteration of aerospace technology, but also a strategic breakthrough for humanity in addressing the depletion of Earth's resources. China, I mean, who needs a humongous amount of minerals for their tremendous industrial capacity, extracts minerals from all over the world. Here in Peru, they have bought mines, they have bought seaports that were concessioned, seaports adjacent to those mining concerns, to have a complete supply chain to China. Peru now houses probably the largest seaport of South America. It even allows docking of the giant Panamax category freight ships, which couldn't enter anywhere in South America, but only Panama, through Panama. And we had to ship all those minerals, probably, I think, to Long Beach in California from China, and each country had to take their smaller cargo ships and bring that cargo to their own countries in South America. Not anymore. So, I mean, this is an amazing change. What happens is that we have these Panamax ships coming from Shanghai to our own seaport, which is called Chancay, but in Spanish. I don't know the origin. And now we from Peru distribute all those goods across South America. We've taken the business away from Long Beach, the port of Long Beach, and it's 1,800. It's a saving of 1,800 nautical miles, around 10 less days of travel. But this example goes on to telling you how China is a huge machinery of obtaining resources. While they are already working on their project, Tiangong Kaiwu, on deep space exploration and mining, the US, which has assembled this critical mineral group, a cartel, is doing this only for Earth. But we need to go to space, as China is doing. And what we follow the example of laws that are already given. Remember when I told you that I made a citation of Admiralty law on the possession of goods in space, Admiralty law, and on the Nostromo. Same thing happens. We translate whichever legal institutions we have on similar issues and mimic them for use in space. The Outer Space Treaty that says that no celestial body can be owned by anybody, by no nation. This, again, comes also from Admiralty law, that nobody, no earth or sea or piece of land that is in international waters can be a, possessed, claim possession by any third country. That's the same principle applied to outer space. So once again, note the impact that space mining is going to have, because for Earth, minerals are being declared critical. So if it's critical, it means that resources are now identified as limited. Well, what's the next step? So humanity has to go to space and mine them wherever they can, in the asteroid belt, and so on. Probably this is like a vision, but I really encourage you to follow this series in Apple TV from For All Mankind. You know, it's a fiction, a science fiction about Russia winning the space race, landing on the moon first, and all the conflicts that take place between the US and Russia. No property can be owned in space, in the moon. In theory, I mean, people are writing about this. They are saying if you set up camp, let's say you're Sweden, you cannot impede that, let's say Russia knocks the door and enters, because again, nobody can claim property in outer space. So imagine the amount of conflicts that could arise. What if I find an ore? Is it the right word? Ore?
Or, yeah, economic minerals.
What I mean is a mineral site. Yeah.
Yes.
Imagine you find a mineral site of platinum,
or
gold, water. What if you find water? You cannot claim it. Imagine you find water on the moon or an asteroid. You're the ruler. Space, even rockets can work in space using steam. So that's what's so valuable about finding water in asteroids. You come with a supplemental capsule that is steam powered, and you feed it with the water that you can find in the celestial body. You work with steam. It's amazing all the amount of technology. But I strongly encourage you to watch vividly this For All Mankind series. It's having its fourth season in March, but it deals, I mean, almost life of the conflicts that will arise based on resources. So I could not give a better presentation than letting you know what a fantastic vision these scientists and screenwriters have had in this series on envisioning and bringing to our screens what could really be a matter of conflict in outer space. Water, minerals, oxygen, property, and you'll see it live. So other than discussing about the technologies that you may find on the internet of all those space pioneers that are doing their task on paving the way for you guys, I hope for me as well. What I want to leave you is with my suggestion to see what perils, problems will be encountered with this hugely hazardous activity. And the impact it can have also on all mankind. I wonder if you have any question. Otherwise, I will leave you and close. That would be it for me.
Okay, very good. Okay.
I did
One final citation, of course, by Neil deGrasse Tyson, that he's a disciple of Carl Sagan, and he says that the first trillionaire will be whomever engages in space mining. I believe him. So I think you are all in the correct activity.
Very good. Levi has a question here.
As far as mining asteroids, would you rather move the asteroids into like a near Earth orbit for mining, or do you think it'd be better to have a ship that could go and collect the materials from the asteroids and then land back on Earth and deposit them?
Actually, I don't have the answer for that, but what I do know, because I've read about it, is that calculations need to be taken on the impact of removing an asteroid on a determined, let's call it ecosystem, because it might be having an elliptic how do you call that, orbit around the sun. It might have a purpose. It may pose a danger. So I think that's up to which technology will be available by then. But everybody indicates that the first issue before reaching that decision is determining whichever risks may be foreseeable on removing that asteroid from its current location.
Yeah, that's a topic that has been very well discussed, and there's some ideas. None of them still practical. The most practical thing that we know is like what we have done, going to the moon and take samples and bring them back. By the way, if you go to Alpine Orbit Museum, you see pieces of that. Is fantastic. But anyway, it depends on the mass and the rotation, or even the mass or the gravity. Because in all the cases, the problem is first gravity, the other is how to handle it, and second, and finally, how to bring it to a place where we need it. So if we go to the asteroid belt and we want to mine it there, either we go there and mine it there and collect it, and then a spacecraft brings back the material. In other cases, if it's rotating, we need to know how to grab it, and then, or how to deal with the rotation and be sure that we can work on it. There are other techniques, like for example, like a sort of catching it with a net, let's call it a net, or some sort of arms, and grab it, and then control that rotation. But that means, as JP was mentioning, taking it out from its natural location, and we don't know if we're going to control that. Other would be being able to grab it, capture it, and put rockets for moving it out of that orbit and bring it to some, let's say, near Earth orbit, and have it as a supply for material. So all of them are valid, but depends on first of the justification of the material that is we have. The asteroids, some of them will be metallic, others non-metallic, and will be other types of minerals, and that will dictate the method that we're going to use, and the cost and the payback if it justifies doing that. But many ideas are orbiting around. Very good. Thank you very much. Thank you, JP. Is this, I guess, your last slide?
Yes,
Yes,
yes.
very good, very good, very good. Well,
So I wish you success, and I hope that we may find ourselves probably in what will be our Peruvian spaceport. Oh,
yes,
we will make this the primary spaceport for space mining.
uh-huh.
I
Very good.
have shared that idea personally with Mitch Hunter Scallion from AMC, Asteroid
Okay.
Mining Corporation, and Matt Jalich,
Uh-huh.
and they are happy but waiting for results from us.
Very good. So here we have Levi Brad, the address of JP and his page and LinkedIn and even WhatsApp. So in case you are interested in keeping contact with him.
I will be delighted. Thank you so much.
All right. Well, JP would like to give you a big thanks for your time and for your dedication on this lecture. And I'm sure that it is going to be very rewarding for our students. And wish we have future opportunities for expanding this knowledge with your participation.
I will be honored once again. Thank you so much.
Okay, let me close this just to see you. Stop sharing to see you. There you go. There you are. Okay, and yeah, well, let me thank you again, and see you soon.
Thank you so much.
Adiós, amigos.
Gracias, gracias. Adiós. Bye bye.
Gracias. Buen día.
Gracias igualmente. Bye bye. Okay, we still have some.